Algebra 1, Chapter 5.4. Chapter 5, we've been focusing on systems of equations. And systems of equations are two linear equations with infinite solutions for each of those. And they want to know where do they intersect? What point or points or no points do they share as solutions? So it says solve the system, explain your choice of method. I'd probably choose graphing here. Or you can choose graphing, or better yet, I'm going to choose elimination. I'm going to multiply everything by 2. I'm going to create 6x minus 6y equals 12. And then I'll just bring this equation, negative 6x plus 6y equals negative 12. So what's interesting about this is that the x's cancel, the y's cancels, and the constants cancels. So a lot of people would say, well, that's no solution. Well, that's not true. If we simplify those, you get 0 equals 0, which is a true statement. And because it's true, that means it is infinite, infinite number of solutions, which I hate that answer. Infinite number of solutions, identity, whatever. I like all points on the line. What does that mean? Well, what it means is these are the same equations. They're the same line. So if we graph them, they're going to lie on top of each other. So if you want to know what points intersect, it's not infinite number. Well, yes, that's the number, but that doesn't necessarily, we don't say one solution, we give a location. So infinite number of solutions doesn't give me the location. All points on the line gives me the location because all the points on the line are where they intersect. So Mr. Mac likes all points on the line. Nobody in the United States or in the world uses that definition. I made that up myself. Most books say infinite number of solutions, which is silly. We got to change that. What are we going to do? Well, again, I'm going to multiply this by 2. This equation stays the same. This becomes negative 12x plus 8y equals 10. This time the variables cancel, but not the constants. The constants actually stay the same. All right, we combine them. That is a false statement. And so that means that they are parallel. Oh, right, let's do this. We should write this somewhere. Same line. Same line. Here is false statement. It is no solution is the answer because they don't intersect anywhere because they are parallel lines. Same slope, different y-intercept. Number 3, well, I guess I might do substitution. Let's minus x from both sides. We get y equals negative x minus 3. We'll substitute that into this equation. So where we see y, we will substitute negative x minus 3 equals 16. 4x, plus 3x plus 9 equals 16. 7x plus 9 equals 16 minus 9. 7x equals 7. Divide by 7. X equals 1. And then y equals negative 1 minus 3. Y equals negative 4. So my point is 1, negative 4. I can plug it in and make sure 4 times 1, positive 12. 4 and 12 make 16. That's good. And 1 and negative 4 make negative 3. So that's checked. Correct. What are we going to do? Well, this is just ugly and not so fun either way. I guess I'm going to do double elimination. I'm going to multiply this. I'm going to multiply this by 2 and this by -3. We're going to get rid of the y's. So that's going to be 12x plus 18y equals -30. Don't forget to multiply everything. That's going to be -12x. That's going to be -18y equals -30. Make sure I did that correct. And we notice that the variables cancel and the constants. So if we simplify this, we get 0 equals -60, which is false. So it's no solution. Let's look at this one. We can just add it. We don't even have to do anything. That's already all ready for us. That cancels, that cancels. What? Did I make a mistake? I think I made a mistake. Are we going to get back-to-back no solutions? 2 is 12. That's positive 18. That's -30. That's -12. That's -18. That's -30. That actually, yeah. So, all right, we're going to get double no solutions. So that cancels, that stays the same, and we get 0 equals 20. So that is no solution also. All right, just checking, I don't want to assume. So I'm going to multiply the top equation by 2, and we get -10x plus 4y equals 6. We're going to bring this equation, 10x minus 4y equals -6. Cancels, cancels, cancels. Leaves me with 0 equals 0, which is true. So I'm going to do what they say, infinite number of solutions. I'm going to multiply the top by -1. I get -x plus 3y equals -9. Let's just bring that around. That's 2x minus 3y equals 9. That gives me x. These cancel, equals 0, which is an okay answer. And then we'll take the top equation, x minus 3y equals 9. 0 minus 3y equals 9. -3y equals 9. Divide by -3. And we get y equals -3. So the solution is 0, -3. Let's check it. 0, -3 times -3 is 9. Top equation worked, of course. 2 times 0, -3 times negative, yeah, that works. That's the solution. It checks. Let's multiply the top by +2. That produces -6x plus 16y equals 64. Let's bring that one over. 6x minus 16y equals -64. Cancel, cancel, cancel. 0 equals 0. That's true statement. So infinite number of solutions. Use only the slopes and y-intercepts of the graph of the equation to determine. Whoopsies. Have I been doing the wrong one? Okay, whoops, sorry, my bad. Let's go back. Sorry. Let's clear the ink. We're going to redo those two problems. Clear the ink. Sorry, Mr. Mac did not read the directions. Use only the slopes and y-intercepts of the graphs. So we need to isolate. So let's take each equation. X, well, minus 3y equals 9. So let's minus x. Negative 3y equals negative x plus 3. Divide everything by negative 3. We get y equals 1/3 x minus 1. Hopefully you could simplify that quickly. That's a good little tester for you. Are you that good? Can you isolate for the variable that fast and efficient with fractions? Divide by negative 3. We get y equals 2/3 x minus 3. So what does this tell us? This tells us, did I come up with the wrong answer too? What was my answer for 7? Well, this tells me that they are not parallel and they intersect at one point. They intersect at one point. They don't have the same slope. So determine the number of solutions. Yeah, intersect at one point. So one solution. Did I solve that? I wonder if what did I do on that one? We did multiply. Oh no, negative. Yeah, we came out with the solution. Yep. So let's take this, negative 3x plus 8y equals 32, plus 3x plus 3x. 8y equals 3x plus 32. Divide everything by 8. We get y equals 3/8 x plus 4. Let's do the other equation. 6x minus 16y equals negative 64. Let's subtract 6x. Negative 16y equals negative 6x minus 64. Divide by negative 16. And we get y equals 3/8 x plus 4. And what do we notice? They're the same line. Same line. So the answer is infinite number of points. Of intersection, right? How many solutions? There's an infinite number of solutions. Let's take this, 2x plus 2y equals 2, minus 2x minus 2x. 2y equals negative 2x plus 2. Divide by 2. We get y equals negative x plus 1. 9x plus 9y equals 9. We should already see what's going to happen. Come on in. I don't know what you want. Shh, I'm filming. You should be in class, not coming in and disrupting my video. Always an excuse. Always still talking in my video. These are the same lines. Same lines. So there are an infinite number of solutions because they're on top of each other. So how many solutions? There are an infinite number of solutions because it's the same line. Let's do 2x minus 4y equals negative 24 minus 2x. Negative 4y equals negative 2x minus 24. Divide by negative 4. We have y equals 1/2 x plus 6. We have 3x minus 6y equals negative 24 minus 3x minus 3x. Negative 6y equals negative 3x minus 24. Negative 6, negative 6, negative 6. More people interrupting my videos. I love it. the people on the video, when they listen to it, you'll be the second group of people who interrupt. So what do we notice? We notice that they have the same slope. Same slope. Slope means that they are parallel, and they are not the same lines because they have different y-intercept. Different y-intercepts means that they are parallel, not the same line. So there are no solutions. They won't ever intersect. No solution, no points in common. These are good questions. I mean, this is really good. So we don't have to do anything in the first one. We can just isolate negative 3x minus 6 divided by 2. We get y equals negative 3 halves minus 3. So what do we know about those? They have different slopes. We don't even have to go any further since they have different slopes. They're going to intersect. Whoa, only one solution. They're going to intersect in one place because different slopes. Number 12, that's an easy one to isolate. Y equals negative 5x minus 3. This is an easy one. Wow, these got really easy. Use only slopes of y-intercept equation term. Yeah, still going. Okay. Negative 5x minus 3. So they are the same equation. Since they're the same equation, they're the same line. So they're an infinite number of solutions. All the points on their lines are the points of intersection. 3 cups of soup and 2 sides of rice cost $15.85. Whoa, 3 cups of soup plus 2 sides of rice equals $15.85. 6 cups of soup and 4 sides of rice cost $31.70. How am I going to do that? I'm going to use elimination by multiplying. I'm going to multiply this by negative 2, which will get rid of my s's. So that equation now becomes negative 6s minus 4r equals negative 8, 8, 16, 17. Negative 31. Okay, you want to do it, fine. So they all cancel. You're left with 0 equals 0. So what does that mean as a solution? Find the cost of 1 cup of soup and 1 side of rice. Huh. Well, they're the same equation. So technically, they're going to be in, right? Did I do that right? 6, 4, double that, 30, 85 and 85 is 170. So what does that mean? So that means that there's going to be an infinite number of solutions. So I wonder, infinite number of solutions. What does that look like? Let's take a little gander, kids. What does that look like for a solution? I think that's it. I mean, we can come up with a solution, I guess, if we thought about it mathematically. If we graph that, we can find a bunch of solutions. Extra practice, answer key. What do you think? Number, there is not enough information to determine. Yeah, right. Okay. It makes sense. Not enough. Enough. And the reason being is, let's show, if we graph this, Let's go to Desmos. Let's write that equation. Let's write both of these equations. We'll use x. 3x plus 2y equals 15.85. And then we can do, what is it? 6x plus 4y equals 3170. Same line. Notice they're the same. If I turn off the blue, you see the red is right underneath it. So we need to understand that this graph represents, so you could have, what's the first one? Soup. If we do x is soup, so you could do soup would be $5.28 all the way to $7.09. Oh, good. Let's keep that there. This is an important thing. And then anything in between it. So these are all of the values in dollars. Now, what you need to be aware of is that's not going to make sense. That's not going to be one of the solutions because you can't have a half of a penny. So, and you can't have a third or 3/10 of a penny either. So $5.28 and 3/10, that doesn't make sense. So you would want to find a grid line. You'd try to find something. Well, let's find the first. No. Yes. Ooh, that would be okay, right? So our soup would be $5.23 and our rice would be 8 cents. So that's an example. And $5.13.23. Those are not no, yes, no, no, yes, yeah, no. No, you can't have 100 or 1,000th. That would be okay. That would not. So these are all the different solutions that you can have as possible. And some of them are viable, not viable. That's viable. And we can go all the way over to here. Now this isn't viable because it's 1,000th of a penny. That's okay. That's okay, right? 5 cents and 7.85. So that's how we would do this problem. Just interesting for you to know. Two roads are represented in a coordinate plane by two lines. Two roads are represented in a coordinate by two lines. Roads A passes through the points that. An equation for the line representing road B is this. Do the roads intersect? So we're going to take that first 2 points and we're going to, this is x1, y1, x2, y sub 2. So 4 minus 0 is 0 minus 3 gives me a slope of 4 over negative thirds. Let's do y equals negative 4 thirds x plus b. We'll take one of those points. Let's take 4 for y. Well, technically that's my y-intercept, but we'll see that in a second when we substitute 0 in for x. We get 4 equals 0 plus b, 4 equals b. That's my y-intercept. This is my slope. And now I can write an equation, y equals negative 4 thirds x plus 4. What do we know about these two lines? Do the roads intersect? Yes, because they have different, oh, sorry. Negative 4 thirds. No, they do not. Sorry, those are parallel. Same slope. And different y-intercept tells me that they are parallel. Parallel and will not intersect. So they do not, so it's just that same slope and different y-intercept. They are parallel and will not intersect. Consider the system of linear equations, blah, blah, and blah, blah. Okay. If possible, find the value of A so that the system of a linear equation has no solution. Well, no solution would mean that they are parallel. So what value for A would produce the same A? Well, 1, when A equals 1. So when A equals 1, that's 1, and then this equals 1 over 1, which still means 1. And they have different y-intercepts, so they would be parallel. So find a value for A. The system linear has no solution, A. They would have a slope of 1 and different y-intercepts, so they would be parallel and would not intersect, so it would be no solution. B, if possible, find a value of A so this system of a linear equation has one solution. Well, any other number, pretty much, because if A equals 3, then that would be 3, and this would be 1/3, and they would have different slopes. They would have different slopes, which means they would intersect. There you go. And 4 would work, 5 would work, 6 would work, -2 would work. Every number except for 1 and 0. So let's do that. Every number, or all real numbers, except for 1 and 0. Parallel. Oh, ooh, 0 with 0. Undefined. Those would be perpendicular. Nope, sorry, it's just for 1. Because if you have 0, sorry, every number except for 0. If you have, or every number except for 1. If you have 0, I think that they would be no. Let's go back to Desmos. I don't think, yeah, 0 is an interesting one. Let's go back to Desmos. Desmos, I think this is the last problem here anyway. Y equals 1 over 0 plus 2, yeah, undefined. Yeah, right? Yeah, I don't think 0. So 0 doesn't work. We'll say for 1 and 0. We'll put it there. Wonder what the answer key says. Oh, not that. Let's see. Answer key. Yeah, sample. I know that. Yep. Good. All right. That wasn't the last problem. This is the last problem. Sorry about that. Write a system of 3 linear equations in 2 variables so that 2 of the equations have infinitely many solutions, meaning same line, but the entire system has 1 solution. Okay, so let's pick a point, 1, 2, and let's write x plus y equals 3, and then let's do 2x minus 3y equals 2 times 1 minus 3 times 2, 2 minus 6, -4. So -4. Did I do that right? Yeah, so we have 2x minus 3y equals -4. That means that these two only share that point. And now we have to write an equivalent equation to x plus y equals 3. So let's just multiply everything by 2. So you get 2x plus 2y equals 6. So these are going to be parallel. And then this is going to share a point, share 1, 2, and this is going to share 1, 2 with that. Oh, yeah, baby. That's it. Have fun. Nice quick video.